Okay, now that we've talked about radicals, which is really our background knowledge that we needed to get to our concept for 6.2, well, in 6.1 we talked about exponents and we talked about exponent rules. So what we're going to talk about today is this brand new relationship between radicals and exponents. And this is one of my favorite things because radicals I found hard to work with, but when you could change a radical into an exponent, it allowed you to do so much more with math. And it allowed you to simplify easier and allowed you to combine things easier and just make things work so much more. And so that's what we're going to talk about today, is radicals and exponents. And so what we're going to start looking at is, why is the square root an inverse operation of a power of 2? So why does the square root of 2 squared become, why do those cancel each other out and become 2? And so what actually we find is the square root is actually what we call a rational exponent. And a rational exponent is really an exponent that is a fraction. And so, for example, the square root of a number is really the number to the 1/2 power. And so when we use our power to a power rule, that anything to a power raised to another power, we multiply those exponents, we find that the square root of x squared is really x squared to the 1/2 power, because that square root turned in to that 1/2 power, because they're really the same thing. So then when we use that power to a power, I'm going to multiply these exponents, so 2 times 1/2 is really the number 1. And so now we just end up with that inside part. And so the same thing happens here. If I have 3, the square root of 3, and then squared, this is really 3 to the 1/2 power being squared. I times those, so this becomes 3 to the 1st power. And so that inverse relationship exists because of our rules of fractions. Half of 2 is 1. And so it allows us to simplify things. So what are we going to do now? We're going to go ahead and we're going to practice just really writing radicals in exponent form. So what ends up happening is the regular exponent becomes the top number. So it looks like exponent over the root. And root is just our radical. So if it's the square root, the root is 2. If it's a cubed root, the root is 3. If it's a 4th root, the root is 4. And so that root is also known as the index. So here this number is really 2, this number is 4, this is 5. That becomes the bottom of the fraction number for the exponent. And then the exponent itself becomes the top. So if I have the square root of 5 to the 3rd power, then the 3 will go, oops, that's backwards. This should be, that's wrong. That's 3 over 2. Because the exponent goes on top and the root goes on bottom. I can't believe I made that typo. I'm going to have to fix that right away. And then over here, I have the 4th root of 7. Well, 7 is really to the 1st power. So I put a 1 on top, and the root, or the index, goes on bottom. And then we're going to get a little tricky. I have the 5th root of 36. Well, 36, tricky, is really 6 squared. So this is really 6 to the 2/5 power, because our 2 is our exponent, so it goes on top. And the 5th root, the root goes on the bottom. So let's go ahead and try a couple together. So the square root of 3. So 3 is really to the 1st power, and this is a square, so this will be 3 to the 1/2 power. And then on our next one, we have the square root of 11 to the 3rd power. So again, this is a square root, so this will be 11 to the 3/2 power. And then we have, let's see, I want a different color. The 3rd root of 13 to the 5th power. So this is 13 And then the power goes on top, 5, and the root goes on bottom, 3. And then, getting a little trickier, we have the cubed root of 9. Well, 9 is really 3 to the second power. So this becomes 3 to the 2/3 power. And then we have the fifth root of 121. So this is really the fifth root of 11 squared. So this becomes 11 to the 2/5 power. And then, get even a little trickier, we have the fourth root of 9. So we have the fourth root of 3 to the second power. So that means this is 3 to the 2/4. Well, I can simplify that fraction. 2/4 is really 3 to the 1/2 power. Which means that I can actually simplify this. This is really the same thing. What's 3 to the 1/2 power? That's really the square root of 3. And so this is written as a rational exponent, but this is simplified. So by knowing how this works, we can actually simplify things way easier, and it makes it easier to work with in the long run. So remember, these are basic skills that we're building on. So as we move up the ladder in classes, we have basic skills to pull from as we start combining square roots and working with them. And where do you see square roots a lot? Well, you see them when you work with squares, and you see them when you work with right triangles. And so all of this stuff builds into construction and engineering, just basic building of things. Okay, so now what we're going to do is we're going to go ahead and work backwards. So the first one we have is 3 to the 3/5 power. So the 5 is our bottom number, so it's going to be the fifth root of 3 to the 3rd power. And then typically you can leave it like that, but it's a good idea to practice what is 3 to the 3rd power. Well, 3 to the 3rd power is 3 times 3 times 3. So 3 times 3 is 9, times 3 again would be 27. Okay, so how about 5 to the 2/3 power? Well, 3 is the bottom of the fraction, so it's a third root of 5 squared, which is really the third root of 25. Okay, so let's look at the next one. 5 to the 8/3 power. So this is really going to be the third root of 5 to the 8th power. Then I should probably figure out, and this is going to be a crazy number, what is 5 to the 8th power? Well, so this will be the third root of 390,625. And so then we have 3 to the 4/3 power. So this is really the third root of 3 to the 4th power. And 3 to the 4th power is 81. So it's the third root of 81. But I kind of want to talk to you about this because the one thing I like about those rational exponents is you can kind of use some rules to break things up. So 4/3 is really 1 and 1/3, right, as a mixed number. And I can break this up because this is really 3 to the 1 plus 1/3, which is an exponent rule. And if I use backwards with exponents, I add exponents when I'm multiplying bases. So what happens here is this really becomes 3 to the 1st power times 3 to the 1/3 power, which is really 3 times the third root of 3. Now I have a simplified radical. So it allows me to simplify radicals without having to do all that division to break it down. Because now all I have to do is turn it into a fraction and work with my fractions, which can be pretty cool and powerful. Okay, our next one, 11 to the 2/3 power. So 3 is our bottom, so it's going to be a third root of 11 squared. And 11 squared is 121. So this is really the third root of 121. And then 2 to the 5/3 power is really third root, because 3 is on the bottom, of 2 to the 5th. And 2 to the 5th, I'm pretty sure is 32, yep. So it's a third root of 32. Or I can use my new handy dandy fraction trick I just taught you. And we can go back in and we can say, well, you know what? 5/3 is really 1 2/3. So then I can break that up as 2 to the 1st times 2 to the 2/3, which is really 2 and the third root of 2 squared, which is really 2 times the third root of 4. So again, using those fractions to help you break down that radical, which is really nice. I mean, square roots are actually pretty easy to break down, but when you start getting the 5th roots and third roots, it can get pretty crazy. And so that's what we're going to be working on today. And then for our very last section, we're going to be doing some of the stuff that I am kind of highlighting for you here, how we use these exponent rules to help us out. So this was an exponent rule thing, and that's what we're going to be talking about. How we can use exponent rules to help combine things, break them down, and simplify.